Lab 1 Constant Velocity. The purpose of this lab was to observe, analyze, and compare an object moving at a constant velocity. This was done in two parts. The first step in Tracker with a golf ball rolling across the surface at a constant speed. In Tracker, graphs and tables were produced. The second part was through code that mimicked the constant velocity of the ball moving across the surface. Then a comparison was made between the Tracker, which is the experimental data, and the code, and the data drawn from the code. The comparison shows similar velocities and positions at certain times. This showcases Newton's second law of motion in that acceleration is proportional to the net force applied on the object. There is no acceleration on the object because there is no net interactions acting on it, making the object move faster or slower in the time given. So in Tracker, I took the mass of the ball and oriented the axis so that the ball moves in the positive x direction. In order to get velocity, it is always the change in x over the change in time, or the change in position over the change in time. So I took the initial position and the next position over the change in time and calculated its initial velocity. And we can see that it has a constant velocity because it moves the same amount of same distance over the same amount of time, which creates a constant slope. In the code, I changed the ball's mass, initial position, initial velocity to match the data in Tracker. And then I incorporated Newton's second law, which is final velocity equals initial velocity plus the net force over the mass of the ball. And since the net force of the ball is 0, final velocity will always equal initial velocity. And then ball's position is the reworking of finding the velocity formula, which is the change in position over the change in time. The output of the code, we can see that it has a similar slope as the Tracker code in that it moves the same amount of distance as it does in the same amount of time because it has a constant slope. In comparing the graphs, the graph showcases similar outputs, both the code and the experimental, because the lines line up. The code creates a perfect scenario, but the experiment differs because there are some outside elements not accounted for in the experiment, causing the lines not to directly line up, but do have similar correlation. If the axes were to change on the graph, however, where the position goes to the x-axis and time goes to the y, we would get a similar output in the lines. However, the slope would be different because slope is calculated by the change in y over the change in x, and in order to get the velocity, it is the change in position over the change in time, which is why the correct x and y axis, when they are switched, the formula doesn't showcase them correctly within the graph. If the axes were to change numerically, slope would change, causing the slope to be negative because time would start at 0.6 or position would start at 0.6, depending on where the ball is placed and initially started, and where the axis is oriented changes the positive or negative value of the slope, but the number stays the same. It just depends on whether the ball is moving in the negative or positive x direction. Since the object was already in motion, there is no net force causing the object to move positively in the x direction. And since it has a constant velocity, there is no force in the negative x direction. If there were forces acting on the object, they'd be very minimal and cancel each other out, causing the net force to be 0 in the x direction. In the z direction, gravity is pushing the ball down, but the force of the ball is being pushed up equally to hold up by the table. And in the y direction, there are no forces acting on the object because it's not moving in that direction at all, causing the ball to have 0 net forces, which gives it a constant speed or a constant velocity. Overall, this lab was to acknowledge Newton's second law, which states acceleration is proportional to the net force applied on the object. Through the process of the lab, no net force is applied since the time is recorded. Since no outside forces were applied to the object, acceleration does not change, causing the object to move at the same speed, which can be seen in the formula final velocity equals initial velocity plus net force over the mass of the object. And since there are no net forces, final velocity equals initial velocity, which is Newton's second law. This law directly relates to the lab because it has a constant velocity. The ball has a constant velocity.